Hey class, Mrs. Anderson here. This video is going to go with Z-scores day 1 or notes that go with 12.4a. So Z-scores. First, to understand the Z-score, we have to review the mean is the average. And remember, you get that by finding the sum of the n numbers divided by how many numbers are total. And the average always goes in the center of our bell curve or normal distribution. So we get our average right here. We sometimes call it x bar or mu, the Greek symbol that we use for that. Then standard deviation describes the typical difference or deviations between the mean and the data. So the standard deviations are how far something is from the average. So we go the average plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations, or we do the average minus 1 standard deviation, minus 2 standard deviations, minus 3 standard deviations. So the standard deviation is how far something is from the average, the distance between the mean and the average. And then the Z-score then is how many standard deviations we are away from the average. So we use this Z-score to show us how far we are. So, you know, if the average is 0, then the standard deviation is 1 here, but the Z-score is how far away we are. Okay, I'll get to that in a second. So the equation to find the Z-score is you take the Z-score is equal to, you take your X value, what data point you're using, you subtract the mean or the X bar, the mu, and then you divide that by the standard deviation. So how are Z-scores related, or Z-scores, how many standard deviations away from the mean and how they're related to the standard deviation? So if your average is in the middle, then you find the standard deviations away, and 3 to the right, 3 to the left. Now, the Z-score for 1 standard deviation away from the average, so right here, then the Z-score would be positive 1. So Z-score positive 1 tells me that we are 1 standard deviation to the right of the mean. Whereas a standard Z-score of negative 1 tells me that I'm 1 standard deviation away from the mean, but to the left, because it's negative. A Z-score of negative 2 then would be 2 standard deviations to the left of the average of the mean. So let's see if we can look at a couple examples here. So here we have a normal curve that's describing daily production. The Z-score for daily production of 2100, given that the mean production is 2,180 units and a standard deviation of 50 units. So remember, we put the average in the middle, 2,180 goes in the middle. And then we add 50 to the right, 1 standard deviation, add another 50 and keep going 3 times, and then subtract 50 to get to the left points. And we're looking for the Z-score for the daily production of 2100. So how far away is 2100 from the average of 2180? How many standard deviations is it away from the average? So to find the Z-score, you use this formula here, x minus the average divided by standard deviation. So your x point is the 2100. Subtract the average of 2,180 and then divide it by the standard deviation of 50. So then we would get negative 80 divided by 50, or negative 8/5, which will be negative 16 tenths, so negative 1.6 is my Z-score. So a Z-score of negative 1.6 tells me that I am 1.6 standard deviations to the left of the average. So it's below the average, and it is below the average negative 1.6 standard deviations away. So this would be a full 50 and then 0.6 of 50. So it's to the left a whole 1.6 to the left. And we're going to use the z-scores to help us find the percents. So when they don't lie on the exact standard deviation, what's the percent of data that it takes up in between those ranges? And we're going to use the z-score table to help us find that. Today, we're just focusing on finding the z-score and then describing like what that means, how far away it is from the average. So the mean is normally distributed a set of data. The average is 30 and the standard deviation is 5. So draw and label the sketch of the normal curve. So we're going to do that first. So the mean is 30 and standard deviation of 5. So 1, 2, 3 to the right. So 35, 40, 45. And then 3 to the left. 25, 20, 15. So there's my normal curve. Now remember that 68% of the data lies between the first two, so this would be 34% between there. We got 13.5% because 95% of the data lies between two standard deviations, so 13.5. And then 99.7% lies within 3, so that gives me 2.35 here, 2.35 here. And we got 0.15 on the edges for that 3%, 0.3% that's left over there. So that gives me an idea of the z-scores here, or the distribution. So I'm going to find my z-scores. So I'm going to use 30 for my average or my mu and standard deviation of 5. So to find the z-score for 40, you're going to take 40 minus 30 and then divide it by 5. So that's going to be 10 divided by 5. So z of 40 is 2. That means that 40 is 2 to the right of the average. It's 2 standard deviations away and to the right. So, and if you look, 40 is 2 standard deviations to the right on my graph. So my average was 30. My standard deviation was 5. So 2 times 5 is 10. It's 10 away from the average. So it's exactly 2 to the right. For the z-score for 25, I take 25 minus 30 and then divide it by 5. So it'd be negative 5 over 5. So we'd have a z-score of negative 1. So 25, the z-score of negative 1 tells me that 25 is 1 standard deviation, 5 units to the left of the average. So 25 is 5 less than 30. So it's exactly 1 standard deviation to the left of the average. A z-score for 31 would be 31 minus 30 divided by 5. So that would be 1/5, which is 2/10. So 2/10 is 0.2. So that tells me that 31, which would be just right past 30, is 2/10 to the right of the average. So 2/10 of 5, 2/10 of 5 would be 1. So it'd be like 1 unit away from the average of 30. So 31 is 1 unit away. It's 2/10 of the standard deviation away from the average. So 2/10 of 5 is 2/10 of 5 is 1. So it's 1 away from the average, and it's positive, so it's to the right. Hopefully I'm not confusing you with my over explanations here. I'm trying really hard to explain it as best I can. So here I get negative 12 over 5, which would be negative 24 over 10. The reason I do that is because then I know it'll be negative 2.4. So I just changed it to tenths. So negative 2.4. So that tells me that 18 is negative, so to the left of the average, 2.4, so right about here. So it'd be 2 whole standard deviations and 0.4 of another standard deviation away from the average. So 18 is to the left and 2.4 away from the average of 30. So it's far below the average. Okay, I think you have the idea for calculating the z-scores. You just take the number, subtract the average, and divide by the standard deviation. This example is filled in on the notes online, so if you'd like to do this example and then check your work, I'd recommend that if you're still a little confused practicing the z-score. But let's look at this one. Class had an average of 75 on a Unit 10 test with a standard deviation of 6. If Marco had a standard score or z-score of 1.25, what was his score on the test? So this one we have to work backwards. So we have Marco has a standard z-score of 1.25. So I know that I can find my z-score by taking my score, subtracting the average, and then dividing it by the standard deviation. So I know that Marco's z-score was 1.25, so I'm going to plug 1.25 for z, and that's equal to Marco's score minus the average divided by the standard deviation of 6. And so now I can solve for Marco's score, which was represented by the x. So divided by 6, I can do the inverse operation and multiply by 6. Oh, I didn't bring my calculator here. Let's see, $1.25 and 6 of those. So $7.50. So 7.5 equals, and then this on this right side will just be x minus 75. So then an inverse operation of subtracting 75 would be to add 75. So let's see, that would leave me with 82.5. So Marco's score on his test was an 82.5%. So I just plugged in what I knew and worked backwards to solve for what I didn't know. If Emily had a standard score of negative 0.45, would you expect her score to be above or below the average? So since her score is negative, that means it's to the left of the average on the table or on the curve, which means that she is below the average score. Not by much, not even by a full standard deviation. So she's very close to the average, but just a little bit below. Let's see what her test score was. So same idea, plug in negative 0.45 in for the z-score. Her score minus the average divided by the standard deviation will give me the setup, and then I can solve it for her score, which is represented by the x. So same idea, since I have a divide by 6, multiply by 6 on both sides. Oh, let's see, 45 times 6. Should have brought my calculator. 24, 27 would be 2.7. So negative 2.7 equals x minus 75, and add 75 to both sides. You're going to get 77.7. So her score was 77.7 or 77.7% or approximately 78%. If you have a nice teacher, that'd round that grade up for you. All right, I think that's it. Oh, there's one more here. It's kind of the same idea. So this one is before applying to law school, you need to take the Lsat, and before applying to med school, you have to take the MCAT. So here's the statistics for that. The Lsat has an average of 151 and standard deviation of 10, where the MCAT has an average of 25.1 and a standard deviation of 6.4. So Juan took both of these exams. He scored a 172 on the Lsat and a 37 on the MCAT. Which exam did he do relatively better on? So since the exams are on different scales, we really can't tell based on those scores. I know that he scored above average on both of them, but I don't know which one is better. And so we can use the z-score because that'll show us how far away he scored from the average specifically. And then that will give us a better idea of which one he did better on compared to the average scores. So if I find the z-score for the Lsat, I'd get a z-score of his score is 172, subtract 151, and then divide it by 10. So we would get 21 divided by 10, so 2.1 for a z-score on that one. The MCAT, I would get a z-score. His score was 37, subtract the average of 25.1, and then divide it by 6.4. Okay, I'm going to have to get a calculator. Hang on just a second. Okay, I got a z-score of 1.85. 1.59, so about 1.86 there. So if we look at like the standard deviations for the Lsat, the average is 151, and he scored 2.1, so he's way up here, 2.1, so just on this side. So that's like in the 95 percentile, you know, he's way up here. This is only 2.5% of the data is over here, so it's actually 97.5 percentile if he's above 2.1 standard deviations above the mean score. So that's a very good score. Now 1.86 is, you know, the average was 25.1. 1.86 is above the average too, but it's just right about here. So relatively, he did better on the Lsat because the standard deviation is higher. So it means, or I mean, the z-score is higher, so he's further to the right of the average. So it's got a better score essentially. So 1.86 is still above the average, about 1.8 standard deviations away from the average. So still scored really, really high, but 2.1 is much higher. Okay, so Lsat was better. Hopefully you took some good explanations away from this video, and I will see you later.